for those of you just joining us now, welcome to the Future of Construction webinar series. Today is day 2 of the series. My name is Kellyanne Mahoney, and I'm a youth program specialist at Autodesk. The topic for today's session is the intersection of robotics and construction. So we are joined live today by Russell from Mass Robotics, who's going to tell us a little bit about Mass Robotics and what they do. But for now, we are working on the warm-up activity. So we're asking for you to think of a robot you might like to design that could help solve a problem in your life. You can tell us about it in the question and answer, and Russell's going to be reading through the question and answer and hearing about your ideas, your innovative ideas for robots that could solve problems.
Yeah, so I see some people are saying a robot chef. That's a very common one. It's a good thing. And then another one is efficient filtering of trash and different recyclable items. And see, I get so a Roomba that can clean stairs and sanitize materials like tile and granite, clean bathrooms. So it's interesting. So I know a lot of these ideas actually, there's some startups and some companies trying to take a swing at this. So you guys have a good mindset for that. So.
Right, so it's just about 1 o'clock now. So I am going to just introduce to you what we're talking about today, let you know how you can participate, and then we'll get more into the warm-up activity again. So today, welcome. This is the Future of Construction webinar series. My name is Kellyanne Mahoney, and I'm a youth program specialist at Autodesk. This webinar series is also a design challenge for high school students. So later on in the week, we're going to get more in depth into the design challenges. We did talk about those yesterday as well. Today, we are joined by Russell from Mass Robotics, and the topic for today is robotics and construction. So right now we are working on a warm-up activity. We're asking you to think of a robot that you could potentially design that could solve a problem in your life. How to participate. So at the bottom of your screen, you should see 3 icons. One is a chat icon. Unfortunately, that is disabled. But the reason why we disabled the chat icon is to protect your privacy. So you can see us, we can't see you. But we can chat out to you. But the best way to communicate with us would be through using the question and answer panel. Also, throughout the series or throughout the episode, we might also ask you, ask a polling question and say, raise your hand, if you have an idea for a robot, or raise your hand if you're following what we're talking about. So that will be there for you, and we might ask you to raise your hand. Raise your hand if you are interested in robotics. How are we doing, Russell?
Oh, it's going up. It's 35 out of 67. It's good. It's kind of like a telethon, It's like going once, going twice.
You got to get those numbers up there, Russell. And I also just want to give a special thanks to Russell. Khalif Mitchell, who is going to be co-presenting today, had an emergency, so he's okay, but he's not able to be with us today. So we're going to be doing a combination of showing the rebroadcasting and encore of his amazing performance the last time that we did this webinar series, but Russell, who is his colleague at Mass Robotics, is also going to be here to help us out as our robotics expert today. So that is how we participate. It seems like you understand how to use the raise hand. Yesterday, we talked a little bit about just the way that technologies are intersecting with the construction industry in order to power the future of construction, particularly around that concept of industrialized construction. So the ways in which the construction industry is learning from the manufacturing industry in order to make the process of construction more efficient, more safe, making housing more affordable, and also just thinking about how it also provides really interesting entry points for people like you who are interested in robotics, or you might be interested in video game design, or you might be interested in flying drones. So we're going to talk to you a little bit about how that actually also could be a career pathway into construction. So 5 of the mega trends that we talked about yesterday that are driving the future of construction are big data, artificial intelligence and predictive analytics, robotics and automation, prefabrication and offsite construction, IoT, or the Internet of Things. So talking yesterday also even just about how sensor technology is providing, generating data for us so that when we are building buildings, it's not just designing and building it and walking away, but also embedding features within the building so the buildings can continue to tell us information as we move forward about how the building is operating. That's one example. And finally, additive manufacturing. So robotics can also be integrated with additive manufacturing. As we saw yesterday, that steel pedestrian bridge that was 3D printed in steel using robotics. Robotics could also be integrated into construction in assembling things that have been prefabricated on the construction site itself. So I also showed you just some of the new roles in construction and how industrialized construction will create new roles for people in the construction industry, making it more accessible as well for people that maybe didn't consider construction to be a viable career path in the past. So there'll be new teams, there'll be new roles, there'll be new skills for existing roles. Russell, do you have any commentary on this in terms of what you're seeing?
Yeah, so yeah, there's a lot of new roles in automation. I think a lot of people, you'll hear a lot of people saying, "Oh, robots are going to take jobs away from people," and I think it's more. That's a huge topic in itself, but you see a lot of new jobs, a lot of new ways. It's more like robots are essentially a tool that you can use, right? So you wouldn't ban a hand drill, right? You would, but it makes things easier. So as things get easier, we can produce more, we can get more quality projects, things can get done faster. So it's very beneficial for everyone.
Yeah, and even one of the themes that is a consistent thread throughout this series is the idea of sustainability. So also just how we can integrate robotics into the construction process in order to make it more efficient, but also to have less of a negative impact on the planet. So oftentimes we can do that and create less waste, for example, by doing construction in a more controlled environment, similar to manufacturing. So this is just some more information if you're really interested in just kind of how the construction industry is reorganizing itself around teams. So, you know, in the future, new roles will include, so the kind of the convergence of design and make. So thinking about those BIM models that were designed in CAD that we looked at yesterday, and also thinking not just about the design of the building itself, but also just the design of how all those different technologies are going to be incorporated in different stages of the construction process, from the integration of robotics to thinking about like managing the drones that might be monitoring the construction site, for things like safety. So just kind of thinking about an integrated plan for the whole process, a manufacturing team that might be working on creating components to buildings offsite, and then also the supply chain team would need to think about how you could move those components offsite to the actual construction site, and also thinking about where we are sourcing the materials for the buildings that we're creating. The production management team, so again, those who might be collaborating with robots in order to make buildings, those who might be flying the drones, managing the drones. Russell, do you want to chime in?
Yeah, so I mean, I think one of the big things is also just even getting a lot of existing construction sites to kind of understand the capability. I always think of so if you guys have ever seen, surveyors, like they have these like tripods, they look like cameras. And throughout the day, they might take different survey points to make sure things are level and things are lined up properly. And the big sell point, a lot of people with drones, they're like, hey, maybe you can do 12 points in a day. A drone can do like a million in like 15 minutes. So just getting people aware of the technology and like also applying it is a big, especially moving forward. So it's a big, that's just getting people being an advocate. And actually, I'm gonna, if it's all right, I'm gonna run and get some demo stuff, if that's okay. I'll be back. So.
All right, thank you, Russell. That sounds exciting. So just another infographic that I thought could be interesting for you to see in thinking about how the future of construction is actually here right now. So robots are already being integrated into the workflow of creating buildings. So you can see in 2019, a lot of this is machine and machine interaction. Robots are involved in both the manufacturing of different components of a building and also offsite in terms of assembling them. So that you can see in the usage section of this chart, that's not really happening very much now in terms of the on construction site assembling by robots, but it is something that potentially could or is predicted to happen in the future, that robots would not just be at the factory creating the building components, but also might be at the construction site helping construction teams assemble the building components as well. So 2025, when a lot of you guys might be just recent graduates from college, there will be more human machine interaction. So that skill of actually being able to collaborate with technology and with robotics and collaborate even with automation, to see automation as a design partner, is something that is going to be important in the future. And then as we get into 2030, you see that a lot of these trends are actually becoming more commonplace, both on-site and off-site, both in the manufacturing, so the pre-construction and also the assembly. And in addition to that, thinking about ways that we can integrate robotics, humans, and some of the construction equipment itself, such as cranes, for example. So I'm going to actually play now Khalif's film. So this is from an earlier iteration of this series. So Khalif and Russell, again, work together at Mass Robotics. Khalif is actually the director of education at Mass Robotics. So here is some of his broadcast from May.
We're beginning soon, but in the meantime, go ahead and start the warm-up activity. Just designing some kind of robot that would help you solve a problem in your life. It doesn't have to be a big problem. It can be a very small problem if you'd like. But the key is to find something specific that you think is better done when you don't have to do it.
And when Russell comes back, we'll continue to go over this warm-up activity as well.
Also, I'd encourage you to write it down. Try to get a good detail in there if you'd like. Sketch it if that helps you. I'll be getting back to that later, so it's good to have that in advance. Can you design a dishwasher? You can. Later on, we're going to talk a bit more about what is and isn't a robot, and does it even matter. So we'll be talking about dishwashers in particular.
Russell, anything interesting in the question and answer?
All right, we are filling up. As you come in, just go ahead.
We have some people saying a robot for cleaning and picking up toys. A lot of like cleaning robot stuff, robot to test things. That's an interesting one. For the cleaning stuff, I saw this one, and we have so it's a Roomba type robot called Rava, and this robot does do cleaning. and in construction, there's actually a lot of robots in the similar, smaller shape that will do kind of plotting out where to put walls and where to put different types of markings, because with human error that can you might put a wall where it shouldn't be, or if it's a very small amount off, but robots can do that to an exact degree. And this is also a small form factor. A lot of robots, they just like this, they just have two wheels here, two motors and wheels, and they carry different payloads and different things. Even telepresence robots now with COVID, people can go to a job site or a job and connect via robot, but still be present. What else here? I see robot for storage and packing. That's interesting. Robot guard. A lot more just came in. An ocean robot to clean trash. That's very good. So
Russell, can you talk a little bit about soft robotics? Because when I think of like a robot that would be in the ocean to clean, I might worry about the wildlife that's in the ocean.
Yeah, so with any robot design, you want to create something that takes into account. I mean, with even aside from robots, you want to be aware of like how it's going to make an impact on society, or just the way people live or work. So so there's been robots that, for example, soft robots that have soft grippers to like pick up fish. I think there's some like oceanographic researchers that use like some sort of like soft netting or soft things so they can tag a fish without injuring it. And soft robots are comprised usually of silicon or something very like a soft material that you can actually often like you can find at like a store, just these materials. And I think also, I mean, so here I have I think I just printed this the other day. You can actually download this on Thingiverse if you have a 3D printer big enough. But a lot of grippers like have a really interesting mechanism. Sorry if I don't know if you can see this, but yeah. So there's just this whole thing was, I didn't have to put this together. This was printed like in one piece. So very interesting things you can do with additive manufacturing and 3D printing. And then, I mean, each layer on this, obviously, if you can imagine, like, oh, could I build a building or a part, or maybe if you're in a construction site and in the time constraints, maybe you need a certain washer, you need something and you just can't find it. Maybe a 3D printer can make this part in a quick fashion, at least for a temporary use, so that people can use the building, things are working for temporary or extended period of time, because 3D printing is really getting up there. So let me look at some more of the questions. I see a robot that opens my curtains. That's a good one, because many of you can actually make these type of things, because if you can buy an Arduino or a Raspberry Pi and a motor and kind of 3D print or tape the motor to your blinds and make them actually open and close. So those are projects that you could actually do. Let's see what else. Okay, a dishwasher. So it's interesting you mentioned a dishwasher, because like I always talk about what is a robot, and I always say like a dishwasher technically is a robot, right? Because it automatically washes your dishes. If you think like in the mindset of a person in the past, say they're like, oh, I have to wash my dishes. If you said there's a device that automatically washes them, it doesn't have arms and a smiley face. So like maybe, I don't know. I have this robot here. This guy. This robot. This obviously, when you see this is like, okay, yeah, it's a robot. It has arms and legs, and it can walk and talk and wave, and it's it's a thing. But in the end, this robot is really impressive and looks impressive, and it can dance. However, it is a lot of functional tasks. Like, for example, you said, hey, I want if I bought 100 of these, could it build me a house or could it wash my dishes? It can't. So there's a lot of specific things. A very common one.
And
So,
about a form of a robot that's, robots, the ultimate goal is to make things more efficient. So sometimes a more humanoid form could be efficient if the goal is for like human interaction with the robot.
yes.
But if it's not, then a human form is not going to be the most efficient form for a robot to take.
Yep. This is a common one, a robot to do homework for you, which, yeah, I mean, that's in the real, I mean, that's more of a software AI thing, right? So if you, I mean, obviously you probably should be figuring it out yourself, because actually, one of the big things a lot of people don't talk about is one of the things that really differentiates people from robots is like creativity and the ability to like versatility and like being able to like do many things. Like for example, some might say, "Oh, if you're working at McDonald's, that's a fast food place. That's not a really desirable job." But or maybe robots would take this job. But if you want to make one robot that can cook, clean, like do all the things that's required of the people in a place, then you have to make 10, 20 different robots to do all these different tasks. So, but as humans, we can do many different things. So it's still leveraging, like, because we have all these capabilities as humans, how can we do more with our capabilities? So let's see some other ones. A robot to feed you when you're injured. Yes, that's a good one. A care robot. That's very important. In Japan, there's a lot of interest in that because they have a large aging population. And even here, it's really hard to get healthcare workers, and even I hate to bring up the elephant room, but like with COVID, right? So if you had a robot that could care for people, then it puts less people at risk, right? So that's always good to have the care robots. See, robot that troubleshoots devices. That's good. Yeah, I mean, a lot of these. That's very interesting. Let's see, a robot that okay, interesting. Fills a pool when it reached. Okay, that's good. Yeah, and a lot of these things. So I see a lot of you could accomplish with even just sensors and a motor. So again, when you think of robot, you might not necessarily have to be like this, like the thing I just showed you, like this kind of walking, talking, has arms and thing. It could be just automated. So which is something that moves and I think Khalif might touch on this in the presentation, so I won't go too much into it, but something that, how you define a robot, something that automatically does things. So.
One question I had for you, Russell, is that when I was just reading up about the future of construction as it relates to robotics and the future of work, one of the skills that was emphasized for construction that I thought was really interesting was mechatronics. Can you talk a little bit about what that is? I tried to wrap my head around it, and I think my head is wrapped around it, but I don't know if I have the words yet to fully explain it.
Yeah. Well, so the thing with robotics, I like to say that no one like if someone says they're roboticist, then they're not really like there isn't any master roboticist that knows everything. Like there isn't one person that you can't just go and say I'm going to learn everything to know about robotics. So a lot of times you can specialize in different things. So and with robotics, it's really interesting. I think a lot of people are interested because you can kind of learn a lot of different things and know a little about this and that, and maybe you really like to code, maybe you don't, maybe you really like to do mechanical work or electronic work, or maybe you like to build things, or maybe you like to design things, or there's a lot of different pathways there. Mechatronics is kind of a mix between electronics and mechanical. So, for example, if you guys know Arduino, like I mentioned before, it's a microprocessor that you can hook up a motor to or sensors to, and basically write code that can help you do things like close blinds, for example. So it's really about and even in mechatronics, people learn like coding and software. So robotics, it's more of finding what skills that you really are interested in, and kind of like learning a little bit about everything, but also, focusing on maybe one or two things that you want to specialize in. Um, Speaking about so I showed a Now robot. So a lot of people, when I present that, they're like, "Oh, you made that robot? That was really cool," because I used to work for the company that makes that. But really, it was like more than 500 people over many years designing, iterating, and fixing, and building, and doing all the things the robot. So a big aspect of any robotic stuff is just working on a team, like with many different people with many different skills, because again, you're not going to know every single thing. You have to kind of, hand it off or get help with it from other people and work as a team to design some really interesting things. So
awesome. Yeah, yesterday, Russell, when I was talking with Suffolk Construction, they also emphasized the importance of being able to collaborate when you're trying to solve big problems. It requires a diversity of perspectives in order to solve them, and that also requires each individual to have those soft skills that are really important in terms of being able to work with people from different backgrounds and different perspectives. Do you think that later on, Russell, we can learn just a little bit more about your background after we watch a bit of Khalif's presentation from earlier?
Sure.
Cool. All right, so I'm going to hit play now. I'm going to try to fast forward beyond the warm-up activity. The Fresh Prince of Bel-Air yesterday. Oh, that's a good place to spot. All right.
That reminds me of the robot.
All right, I'm just trying to fast forward a little bit from the warm-up activity.
Absolutely no limits here. Robot to tell me to eat left Twix or right Twix.
This is making me think, Russell, can we create a hologram of Khalif?
That can do what you some final rope.
All right, this is getting into what
Button, so I know you guys all know that right there. Look at that, very quick. All right, awesome. Looks like you guys are all on top of it. Right. So first question, obviously, is what is robotics? I know we all have some kind of idea of what it is, but we want to get more specific now. So robotics as a field is all about the design of the robot, which is what we're doing before. It's the what is the purpose of the robot, and then what are the things that we need to put to give this robot so it can do the things it needs to do. You have the engineering side. So now once you have the design, then you have to actually engineer the thing. This is when you start. Figure out how exactly can we make the design a real thing. So once you have the design, you've engineered it, right? Someone actually has to operate a lot of robots. So some robots work on their own and others work in tandem with humans. So the ones that work with people actually have people working alongside them in order to operate it. And also the application, so installation and such, all has to be done by someone. So these are all things within the fields of robotics, of robotics and automated systems. I won't get too much into the difference between a robot and an automated system, but just know that there is some nuance there. Right, so what is a robot? A robot is anything that can sense the world around it, takes that data, computes it, and then actuates it in some way. So the term actuates, what we use in robotics, really it just means moving things. So that's something like an arm, right? That's actuation. In a car, a wheel, right? Something which actually moves. It's not just a digital computer thing. It has to functionally move something somewhere. Otherwise, we can't quite call it a robotic system. So I want to go over some robotic systems. This one right here is the NASA Valkyrie robot. We have one in mass robotics. And this looks a lot like what I imagine many of you think of when you think robot. We have an idea when we think of robots that comes from a lot of media. And while this is broadening these days, this still is a trademark version of a robot. But even this robot, right, it has to go with the same rules that we gave for all robotics. So it has to have some way to sense the world around it. In this case, it has infrared sensors, which are a type of sensor that can sense distance by sending out two different signals, one that sends out a signal, and then one that will receive it. And using that, it allows it to figure out the distance between objects. And then this one also has cameras on its front and on its back. Important thing to notice for this is while it looks a lot like a human, it has cameras that are located in the torso area, right? And this is one of those things which, at first glance, you might think you want to put the cameras in the head, right? That's where the vision is. But we're not robots, right? We're not bound by the same laws that humans are when we design a robot. So a camera can be put wherever it's best utilized. You could put a camera on the robot's hand if that would help it serve its function. So in this case, it has one. They're called hazard cameras in order to sense danger, right? So the compute side is the interesting part for this particular robot. So the infrared sensors, it's a little more complicated than just an infrared sensor, but the idea is it can take the data from the distances objects are from the robot and can turn those into points that can create full 3D models of spaces. So the image you see right here is one from the sensor being used in the NASA Valkyrie robot. And it can map a space as it's moving through it. So this gives it eyes, kind of like what we have. And then the actuation is the legs, the arms, the wrists, the head, right? So robot. Now this is a manufacturing robot made by Universal. And at first glance, we might think, okay, this, I can see the actuation. It has a whole bunch of joints. And you can see this actually has more joints than a human arm, right? So you have the joint at the bottom, the joint at the middle section, then there are a whole bunch around the arm, around the hand. But even this type of robot has some types of sensors. This particular one might use a force torque sensor. Now that sounds super fancy, but all it really means is it gives the robot a sense of touch. But a sense of touch doesn't mean anything unless you have something you want to do with it. So the compute for this one is a control box that you can see at the bottom, and it will take the data from that force torque sensor and uses it in some way based on how we program it. So an example of why we might want this kind of sensor is, say you wanted to pick up an object, right? Now, if you wanted to pick up a rock, you could use any kind of force. You could just hold it in your hand. It's not going to go anywhere. It is not going to break, right? However, if you wanted to take the same robot and you want to pick up an egg, it needs a much more delicate touch. And without the proper sensor, the same robot would just crush that egg. And that's one of those problems that is surprisingly common, even right now, to have robots that have some kind of dynamic understanding of what they're holding. So I have an exercise for you guys. I have 3 things here. One of these is an automatic door. One is a washing machine. Remember I was gonna get back to the dishwasher before? Washing machine is a similar deal. right? And then you have a desktop computer. So I want you guys to raise your hands if you think an automatic door is a robot.
So y'all can raise your hands now. I'll pause, Khalif. So who thinks an automatic door is a robot? How are we doing, Russell? Because I can't see.
It looks like we have 55, 56, 58, 60. Yeah, a lot of people, the majority of people.
All right, let's see what Khalif has to say. Oops, I just messed up the video. Okay.
Uh,
I went to the next slide.
Again, where
were we?
things.
All right. And I just did it again. I'm sorry, guys.
In, we're beginning soon. One of these is an automatic door. One is a washing machine. Remember I was gonna get back to the dishwasher before? Washing machine is a similar deal, right? And then you have a desktop computer. So I want you guys to raise your hands if you think an automatic door is a robot.
All right, so we took our poll here already.
Looks to me like we have about half of us think an automatic door is a robot. If you say it's a robot, I want you to go in the Q&A and tell me why it's a robot. Remember to use the sensing, computing, and actuating, right, as our criteria.
So you can do that in the question and answer as well. I'm just going to try not to be fancy and touch the recording.
Right? So a lot of the answers are, it has a sensor, so it knows when someone's near it, and then it moves itself, it opens, right? And so yes, automatic doors can be classified as a robot, right? Even though we don't necessarily think of it as a robot, the fact that it has some way to sense the world around it via a sensor at the top.
And by the way, you guys had similar stuff. You keep going. You had similar sensors, yeah.
Thank you,
At the
Russell.
bottom, right? That senses when someone steps near it. It uses that to sense. And then again, sensing data on its own doesn't do a whole bunch. So something in there has to compute, okay, when there's someone nearby, open the doors, and that's the actuation, right? So that qualifies under this definition as a robotic system. Now, a washing machine. Is a washing machine a robot? Raise your hand if you think so.
All right, what do you guys think?
We got 38, 38, 38, 40. We got 40, 44, and 42.
So this one, a lot fewer people think of a washing machine as a robot. Looks like about a quarter. And so if you think it's a robot, I want you to tell me why.
So you can answer that in the question and answer.
Okay, so this is a bit of a trick question. It's a trick question because it kind of depends on the type of washing machine you have. If you have an old type of washing machine where you told it exactly how big the load was and what temperature to put it at, right? Then it's a lot less of a robot because you've given it all the sensor data that it needs. You've told it how much is in the load, you've told it how long to go for, and you've told it what heat or what have you, right? So that wouldn't qualify as a robot. However, more modern washing machines often have load sensing, so it can now take the clothes that you put in, and it will know how many clothes and therefore how long to actually run a load for. So again, that one depends on the type of thing, but you can see how the definition of robot itself is kind of loose, right? The last one is a desktop computer. Now this one, I will tell you in advance, is also similar to the washing machine. It kind of depends on the computer. But in this case, I pulled up a picture of this one here because it has several things, including a fan system, including a water cooling block that does have a pump in it, right? So I want you guys to tell me using Q&A if you think a computer is a robot and why.
So you can let Russell know in the question and answer what you.
I see some people saying no because its first step isn't sensing. Okay. Automatic fans. Okay. Temperature sensors. Okay.
If the CPU gets hot.
I'm muting Khalif so you can talk, Russell.
Oh, okay. Yeah. No, I'm just seeing all the answers here. And so most of you guys have the right idea. So there's limiting fact. So in the CPU, if it overheats, also when say you're playing a video game and your graphics card or the computer starts working and the fan gets faster, it's sensing that, oh, I'm getting more hot. I'm going to turn the fan on. So.
Within the cooling system of the computer. And so while you can call it a robot, right, and it fits our loose definition of a robot, because it doesn't, those things in and of themselves aren't really primary function where, using a desktop computer, opening up applications and such, they're kind of secondary systems to the computer. So we can call it a robot, we can call it not a robot. Ultimately, it doesn't matter a whole bunch because robots are not just about, is it a robot? It's also automated systems, right? So those are the two things that fall into the robotics term. So a lot of the things in a washing machine or a desktop computer, we can call robots or we can call just automated systems, right? They are two different terms that both help you understand what robotics is. There is one answer in here that says, but a computer doesn't move, right? Same thing with the washing machine. And I want to clarify that actuation doesn't always mean move in space, right? A fan has a moving element, same thing with the washing machine that tumbles around. So they qualify as actuating, which is why we use that term as opposed to just move. So why use a robot, right? Why do we make these robots and design these automated systems, right?
Yeah, could you just pause here really quick? So I'd like to add, so I mean, the definition, even with like doctors and roboticists and people like me, is pretty, it's always, it's not very, everybody has a little slightly different definition of robot. I think though that a good way to say it is that if it has any sensing whatsoever and also takes action on that sensing, then it technically is a robot. So like the automatic door, it's a door. You wouldn't be like, hey, look at this robot door. It's just a door. But technically it's automation. And I think what's interesting is I think one of the reasons also to talk about this is that, everybody can't just make these magical robots that do walk and talk, and it just doesn't make sense and it's not effective. So looking at careers or projects that have automation is really interesting, and it's basically the same thing as robotics. It's just kind of in a less, some might say less glamorous. A lot of people like, oh, you're making things happen automatically, but again, you're helping people, you're making things happen more effectively. Some people, like for example, like a robot that cleans the ocean, if it's just a ball that absorbs things and senses it and then spits them out, or degrades them or whatever, then who cares if it has googly eyes? So
I personally love googly eyes, though, Russell.
yeah.
All right, so we're going to continue to play and hear what Khalif has to say.
Thing that people use when they think why we use a robot. So the first one is for dull tasks that no one really wants to do. So, for instance, sorting trash was one of the robots you guys were talking about earlier. Washing laundry. If you've ever seen old images of people washing laundry with kind of a board, and they're scrubbing against the board, and then they're drying it up on clips, right? You can do it, but you'd rather something else do that, right? Dirty tasks. So things which are just a lot filthier than we want to put, filthier condition than we want to put humans in. So a lot of things like sewer inspection, for instance, right? I don't think there's anyone here that is all too keen on hopping in a sewer. Another one is anything dangerous. So those are your basic 3Ds. Danger in this case, think of a bomb robot, right? A robot that goes and tries to defuse a bomb, so we don't have to send a human to do that. We'd much prefer a robot to do that because obviously there's danger there. I like to throw in also very precise tasks. So there are a lot of tasks which are just far too precise for a human to do accurately, consistently. So a lot of your 3D printing, for instance, right? Heavy machinery uses some type of automating system in order to make sure it's always doing things correctly. So in general, it's things we can't do, or it's things we could do, or would rather not. And then there's things we can add so that people can work more efficiently, right? The example I have here is the robots you use at Amazon. So Amazon robots are a lot of fun because if you've ever seen robots that take packages around, right, or people can put a parcel on a robot and it will fly around, that's cool. Amazon just takes it one step further. And the way their system works is they have that little orange robot at the bottom that will pick up an entire shelf of goods, and they will bring it to a person, and that person will then pull out the item that you ordered before they ship it off. So instead of it being one thing at a time, they'll just bring a whole shelf over, which I think is super cool. It is, using this understanding of robots, right? We can see there are a lot of applications for it. It hits almost every single industry in some way. So if you guys have any questions, now is it.
All right, so I think it's a good time to pause. And we have about probably like 13 minutes or so left. And I figured this would be a good time for us to just kind of talk, and Russell can talk a little bit about his background in robotics. I'm going to stop sharing the screen so that I can see the comments as well. But Russell, anything interesting that happened in the comments while Khalif was presenting virtually? This is a virtual experience with a virtual presenter, which is just cutting edge.
Yeah, it's Inception over here. So I saw some question about cost effectiveness of robots. So that's very important. I would say I think that's another factor that leads to a lot of robots being created, is that how can you save money with the robots? Also, the robot itself, it's kind of interesting because I'm sure everyone has seen the Boston Dynamics, like the big dog robots and all those YouTube videos, and it's so cool and it's like scary or whatever you think about it. But when you say, oh, cool, I want one of those, how much does it cost? It's like $75,000 just for nothing, just like no sensors. Like, well, I mean, it has sensors, but no like advanced mapping and things that, you know, if you're a researcher, you'd be into. So it's like maybe $100,000 for that robot. And another thing is, so earlier, I think a really interesting example of this is someone mentioned a robot to cook for you. So, okay, so if you want a robot chef, the interesting thing with that is that, okay, so, you know, let's say a robot chef costs, I mean, judging at how much motors cost and things cost, let's say you could get that to $10,000 or $20,000, like something, a robot chef for $10,000 or $20,000. So the price of maybe like a car, which, I mean, it seems expensive, but fair. I mean, you know, if you're gonna have a robot chef, you know, once you have a robot chef, though, you know, they still have to pay to maintain it. You still have to give it food. It still has to like to cook for you. You know, a lot of people might say, oh, for that amount of money, I could go out to eat dinner, like takeout food for the whole year, or I could just say, you know what? I'm gonna cook it myself. Like if you're, I'm pretty sure most people here don't have like $20,000 to spend on a robot chef. You rather spend it on, you know, something else. Sure, if you're mega rich and you have a mansion and you want a robot chef, maybe, but that's not a huge market, I feel. So a lot of people have difficulty making these type of things happen. I think a lot of, and there's a lot of stories about companies that made robots that were really interesting and fun, but they couldn't sell them because it was just too expensive. So let me see some other questions here. I like to try to answer as many questions as possible. So see, how could robots and humans work together in other jobs other than construction? So I mean, there's a lot right now, collaborative robots, industrial robots. If you look at collaborative robots, that's a big thing. Back in the day, you know, it used to be like if you're building a car or some other item, the robot would be in a cage. It's very dangerous. It moves very fast. It's very dangerous to be around. So you wouldn't get near it. But now they have robots that have you could work right beside them, like it will pass you something and keep on going, and you don't have to have a big cage and protection. You still have to have some safeties, but if you get bumped by it, it will detect that you're near, slow down, and then if you do get bumped by it, you're not going to get like, you know, your arm's not going to get knocked off. It's just like it will bump you and say oops. So yeah, I guess I can talk really quick about my background. So I used to work I went to school. Most of the crowd here local? Are you guys like from the like Northeast primarily? I went to Bridgewater State College, so that's like a local school for computer science. And they didn't have a robotics degree, but I joined a robotics club and really focused and was really interested, and I learned like coding, and I found that I don't really like coding that much. I mean, I can code and I will code when I need to, but I rather have a job working kind of more hands-on, more technical side of things. And I've worked for SoftBank Robotics, which makes the Pepper and the Now robots for a while, for like almost 5 years. And I traveled the world and did a lot of fun stuff. It was a very interesting career. But you know, it's something. There's a lot of things that you can do in robotics or around robotics and be really proud and part of a team that's creating a product that's kind of this culmination of everybody. You know, I always I use the example of well, I won't go on, but that's yeah. So there's that. I don't know how much more time or what else we want to cover.
Does anyone have any other questions for Russell, just about learning about his background? Even if maybe you're interested in a robotics career yourself, maybe you have some questions in terms of how, what steps Russell took, or maybe what Russell was like in high school. That would be interesting to, to dig into right now. So any questions for Russell?
Yeah, so I see a bunch. What did I major in? So you can major in technical things. The other thing I like to say too is that when I first even after college, I had some difficulty, and as a fallback, I did technical support because people always need IT support, and if you're technical, it gives you some good chops and good like practice learning how to fix things and work around things. Um, I was always interested. So I say some things. What interests you in robotics? Ever since I was a kid, I loved movies like Terminator. As like cliches, I had all the action figures, and I loved Short Circuit. If you guys are familiar, it's like the grandfather of Wall-E, basically. I used to love those type of movies. Let's see. How much do math and physics apply to robotics? So they do apply. However, I mean, if people get really caught up in math and physics aren't your things, an interesting thing I always tell people is again, it's a field that there's actually a need for this sweet spot, I call it, of like somebody maybe that knows about electronics and robotics and knows some basics, and also maybe they're a marketing person or a salesperson, they understand it. So these people, because a lot of engineers are very like they don't really get like marketing or like dealing with public or whatever, and then there's also marketing people that are like, oh, whatever, don't I don't care, I don't know anything about tech stuff. So if you kind of hit that middle area, that's really beneficial, and it really opens a lot of doors, kind of having that multi kind of crossover. And you don't have to be a super, again, there's no like super expert in everything in robotics. You're usually specialized in like vision. Like you can say, I want to work on self-driving cars, so I'm gonna specialize in vision, or I'm gonna work in building the motors or the parts that are used or the sensors, or putting it together. So there's a lot of things to do that. So again, you can do mechanical engineering, electrical engineering. I mean, I know like WPI has a robotics, like there's a lot more schools that are offering straight out robotics and combining that. I would say, honestly, a huge thing, and I'm sure a lot of people might roll their eyes, but YouTube stuff. Like you learn about, like I would buy Arduinos, Raspberry Pis. They're only like 30, $10, $30, and you can do so much, get some motors and kind of play around, even like hack into some, if you have some broken electronics or things, try to fix it, like really try, like don't be afraid of it. Obviously, be safe, what if you gotta open something up, make sure it's not plugged in, make sure you know what you're doing, and like kind of research it a bit, but like give it a shot. Like it's kind of like being a magician in a way, right? Because I'm sure, I don't know if you guys, you might have dealt with your parents before, and they're like, oh, can you fix something, and you just like, it's just this button, you just press this, what are you doing? And it's like, whoa, you're so smart, oh man. And you get this feeling like that was so simple, why didn't people figure this out? And I think if you learn about electronics and how to fix it, you can, you don't have to know every little piece of, like I know, even so with the robot here, I showed you the now here. So fixing that, I did a lot of repairs on that, and often, I mean, you could go and like solder things, but often people just replace the board, move on. If something's broken, they just replace the power supply board. Let me see some other questions here. Okay, so okay, so I see. What do you enjoy most about your job? I really liked. Well, I liked traveling was really fun. So if you like to travel, you can find jobs. A lot of jobs in robotics actually, well, technical side, they might involve traveling because you're visiting. A lot of times, robots might be big or bulky or very specialized. So they might just say, you know what, it's going to be too much of a pain to ship this somewhere. I'm just go to that place and fix it, or go to that place and check it out. So if you like traveling, sometimes there's a lot of robot jobs in traveling. And then on the other side, coding is also, you can get paid a lot of money, and but you don't feel like traveling a lot. I see. Oh yeah, another thing I liked about my job was that you kind of, it's, robots are interesting, especially the ones I work with, because like they have this kind of personality. So people, I almost felt like a doctor, like helping. Like they used to, for example, we did this thing called RoboCup, which was robot soccer, And like basically, if the robots broke, we'd fix them really quick and patch them up so they can go out and play again. And you kind of feel like this like doctor fixing up these silly robots that keep falling and breaking their gears. So there's that. What other things here? Is AI being implemented in robots? Yes. And the other thing is, a lot of people, what I kind of, what you have to get used to a lot in robotics is a lot of people will say like, oh, Skynet, oh, the robot's gonna take over. Oh, you just hear this over and over. And once you work in robotics and see, you're like, oh man, this is not the situation at all. It's like the robots are pretty focused and very, I remember what I would happen is like, so for example, I would take this robot and I'd be setting up for a show and I'd be like, okay, let me put this guy on this is his little shirt on too. So I'm gonna put him on a desk and I didn't even press the on button yet. But then people come over and they say, oh, hi, little guy, how are you doing? Oh, hi, what's your name? And they'll start talking to the robot. It's not even on. So people are very, like, the expectation is, like, very high for robots. And then even when I did turn it on, it can't respond to everything that you could imagine. So there's a lot of, I think now with robots, it's really hard to program like every situation. The other funny thing that's kind of a aside for that is that we had, for example, Pepper. Sorry if I'm going on about the story, but we had this robot Pepper that we put in like a Best Buy type scenario and said, okay, if you had Pepper in the Best Buy, what would you want it to do? And like all the software creators and salespeople, they're like, oh, we want to have a map and tell people prices of things and sales and things like this. And that's great, and it makes sense, and conceptually that makes sense. But then when you actually put it in the store, the first thing people go up, they're like, "Oh, cool, robot. Hey, what's your opinion? Are you a boy or a girl? What's your political opinion? What's your favorite color?" And a very crazy questions that you would never anticipate. And then the robot will say, "No comment," or "I don't know." And after a while, people keep asking these crazy questions, and if the robot just says, "I don't know," just to be safe, then people say, this is stupid. This robot's stupid. It's like, it's not worth my time. It's silly, which is interesting because it was deliberately not answering those questions in that way, so not to get in trouble or say something, And the other thing is, like, even if you were a company and you said, okay, I want to say my robot says, hey, guess what? I'm a vegetarian. Like, I don't approve of people that eat meat or something like this. And then all these people will say, oh, this robot's mean. This robot, has this crazy opinion. So it's very tricky. It's a very difficult, especially in social robots. It's very difficult to figure out what people expect, just because of all of the movies that you see and things like this. I think the real thing is just finding like products or things that you might enjoy. So for example, like, okay, so I get these headphones are like Panasonic headphones, right? And you could say, okay, I wonder how they made these headphones. And you could like look and see like, oh, they had like an assembly line and like there's a robot that actually like solders this thing or this or that. And then you can apply to those companies, say, hey, like I'm interested in this aspect or this aspect, and it might take you down a really interesting road. Or you can try to build your own things. It's very broad, as you can do a lot with robots and construction too. Like you could say, hey, I'm gonna help out at the job site. I'm gonna fly a drone to give you a analysis of how the construction's going. I'm gonna plot lines so you can know where to go. Maybe I have a robot that keeps track of all the, it must be really hard to, like, you're not going to count every screw, but like if, keep track of what's available in stock. So yeah, so I don't know if there's anything. There's a lot of questions. Jeez.
Well, Russell, let's maybe answer like one or two, but I just want to say thank you for doing such a great job of demystifying robots for us. And just to reiterate your point about how, there's a lot of human input that goes into what robotics do in many ways that they are reflection of us, right?
Yeah, I would also say, I mean, every time you're designing or thinking about robots, always think of like the human aspect of it and how it's going to affect people and how, things, will happen. Like I know, like now, there's a lot of interesting things. Like for example, even with I think what is going to be interesting, but it's probably going to be uphill battle, is like even like more political or governmental automation, right? So I'm sure everyone's like, I mean, maybe you're too young for this, but like taxes, like man, how can we automate taxes? How can we automate voting? How can we make it in a way so that people can vote safely and officially, remotely, and that's really tricky without people like making a fake vote or making something up with it with digitally. So because we've seen it online in the past, right? I'm sure you've seen somebody will have a poll and like they'll have a bunch of people or a bunch of accounts and they're not real accounts, but they'll get a bunch of upvotes even though it's fake accounts. So we got to be careful with that. But I think solving those solutions, it's kind of like you have to solve a problem to solve a problem, solve a problem. So it's this big like kind of cascade thing. So yeah, very interesting. This whole time I've been playing with this. You guys can share. It's really fun. So.
All right, so we should probably sign off soon. But I just want to thank you again, Russell, joining us from Mass Robotics. Do you want to give a pitch of what Mass Robotics is before we go? And then
Sorry, yeah, sure. So Mass Robotics, we're a nonprofit co-working space in the Boston Seaport. So right across from Autodesk, and we partner with Autodesk on a lot of interesting projects. And so we are a co-working space for robotic startups. So basically, if you a lot of times a company might have an idea prototype, you have some basic thing you maybe built in your garage or you went through accelerator program, and once you're like, okay, I really want to make this a business, we have office space. So I'm actually in an office right now that's not occupied, but somebody could rent this space, and then we have a lab, we have 3D printers that you can make stuff like this, we have a lot of tools that normally would be like a laser cutter and different hand tools and soldering stations, and also like connections to the community. So we really try to help the robotics community kind of happen, which it's tricky because again, as you can see, it gets confusing if you don't have people talking about robotics in this way. People will just be like, oh, it's Skynet, people are taking jobs. In reality, it's like we're actually making jobs to like get us like a quick thing too, like I mean, I always like look at like, okay, so a lot of people, it's just crazy to think that you could buy like something that was made in China for so cheap, have it put on a boat, sent over to America, and buy it, and it's still cheaper than just making it in America. So I think it's really interesting to use robots to like make more things in America, and make, I don't know, really cool stuff. So yeah.
well, my dog is barking right now. That's why I was on mute. Maybe I need one of those Boston Dynamics dogs that don't dare to hear me. But so
75.
well, we've been taking them home. I saw that in the news article about roboticists and taking the robots at home during the health crisis. So just wanted to let you know, thank everybody for sticking with us today. The future of construction requires flexibility and adaptability and teamwork. So I think that with Russell's help, we achieved that today. So tomorrow we are going to be focusing on the sustainable community. We're going to have the Boston Society for Architecture presenting, and also EcoRise, which is a group in Texas that does a lot of work actually in Massachusetts to support teachers and students in learning about the concept of sustainable intelligence. And they're also going to talk a little bit about how high school students, which is you, could also achieve LEED certification, which is an industry recognized certification that you can get as an entry point into the construction industry around sustainability. So that's tomorrow. You will use the same registration link as you used today, same time. We're starting at 1, and I'm sure the guests will stick around, just as Russell has graciously done so today, to answer your questions too. So thank you again for joining the Future of Construction webinar series. We look forward to seeing you tomorrow. Take care. Bye, Russell. Thank you so much.
You build some cool stuff with Tinkercad too. That's really great.
Yeah, totally. All right. Thank you all. Take care. Bye.